of contact, and that's a tangent. Tell me about angle between radius and tangent. Come on. Angle between radius and tangent, please. That is a 90. It's a right angle. Angle between radius and tangent. Do we have another radius and another tangent? We will see. Let's go. There we go. CD, the green line here, is a tangent, and OD is the blue line, which is radius. Angle between radius and tangent, we learned the rules, we know that's 90. That complete angle there, full, is a right angle, please. Right? Now, these two are equal, that's a 90, that's a 90. We don't know what's that, we don't know what's this. But let's just go and study the remaining picture. From part 1, if you know that rule, if you recollect that rule, do we have angle at the center? Come on, people, angle at the center made by BD. Made by BD, is there an angle at the center? Yes, right. That angle there, okay, that's the angle formed by BD. The same BD makes an angle at the circumference. The remaining part there, that angle is made by BD. If that's a 52, how much should this be? You all have learnt these rules in part 1 and 2, right? Even if you haven't watched, you should know these rules to solve this sum, please. So, angle at the center is double the angle at the circumference. So, that's a 52. That should be 104. That should be 104, right? We got this angle now. That's a 52, that's 104, and we are happy. What about this angle here? Can you find this angle? That much only. And can you find this angle? This much only, please. Think about it. Do we have radius? Do we have isosceles triangle? OB is a radius. OD is also radius. So, according to the rules, those two should be equal. And watch there, that side is equals to that side. By the way, can you compare the equal marks there? I have put only 2 here to show that these two are same. I did not put 2 there. I put 3 marks, equal marks there. So, if you put only 2, it says those two are equal. So, please be careful, right? Now, OB equals to OD. The top angle we know, isosceles triangle, base angles should be equal. Come on, you can do this, right? So, from 180, we are taking that away. Take the 100 away first. If you take the 100 away, we got 80. Take the 4 away, we got 76, right? We are going to divide 76 into 2 equal parts, please. How much do you think this angle will be, right? 38, come on, 38 degrees, that also is 38. Okay, so simple. Come on, we applied the concept of isosceles triangle. Now, well, we are finding all the missing angles there, okay? Now, that's a 90 we know. That much is 38, right? That much is 38. Is there a way you can find this angle here? Come on, 90 minus 38. Take the 30 away first. We are left with 60. Then take the 8 away. It should be 52. Am I correct? Come on. That should be 52. So, watch there, please. That angle there should be 52. All right? So, now, if that's a 52, obviously, this side also, this angle should be 52. Okay? Now, this is how you need to apply the rules slowly, one after the other. Right? Anything more? Well, we got a triangle there. Watch, BDC is a triangle. It's an isosceles triangle, please, because these two sides are equal. That's the base. The black line there is the base now. Base angles equal. Right? We are looking at this angle. Well, there are 2-3 ways to find this angle now. I will take you through those 2-3 ways, please. So let's just waste a little bit of time here to see how many rules we can apply. If you go back to part 2 that we have learned, right? Those who watched my part 2 of circle geometry, we did cyclic quadrilaterals. What is the speciality? What's the importance of a cyclic quadrilateral? Come on. Opposite angles add up to 180. So in a quadrilateral, if the opposite angles add up to 180, I have a right to say it's a cyclic quadrilateral. We can use that rule here if you carefully see it, right? Let's go and see. That's a 90. Well, I'm talking about the quadrilateral OBCD. OBCD is a cyclic quadrilateral even though I'm not able to see a circle passing through, right? A circle is not really passing through those 4 points, but I can say that it's a cyclic quadrilateral because angle at B is 90 there, watch, and this is also 90. So opposite angles are adding up to 180. These two also should add up to 180 because it's a cyclic quadrilateral. Now, if that's a 104, how much should this be? How much should this be? They add up to 180, please. It should be 76, right? 76 add 4 will be 80. So I'll write the angle here as 76. Okay, let's go and use a yellow pen and see how it works. That's a 76 there. 76 degrees, that's on the screen. Okay, so we applied the concept of cyclic quadrilateral to find this angle. But if I turn the picture like this and see, now let's assume we don't know that. Concentrate on BDC triangle. We know it's isosceles because 2 sides are equal. Base angles equal 52, 52. We can use the concept of 3 angles of a triangle. Add those 2, come on, then we take away from 180. We get back 76. So there are so many ways to actually find those missing angles, right? Now, another thing. As I told you, from part 1 and 2, you got to know those rules. Unless you learn those rules, you cannot apply tangent properties. So when you look at a question, you cannot have only a tangent and a radius. Okay? So there are so many things joined in just one sum. So please be careful. All right?